In a way, I love describing vultures as the great disinfectors of the environment. They're like spraying bleach over our surroundings. That function that they perform out in the wild provides us with this service of public sanitation, which could potentially be very prohibitively costly to try and replace and substitute should vulture species were to experience massive declines in their population levels.
Hi, all. Before we dive into today's episode, here's today's Wild Guess trivia segment. In the last episode, I asked you to name when and where the last climate COP hosted in South America took place. The answer is Peru in 2014. For this week, most vultures are bald headed, but there's at least one species of vulture that has hair on it. Can you name it? Drop your guesses in the comment section on YouTube or Spotify, or email us at naturebreaking@wwfus.org. Good luck. Welcome to Nature Breaking, a podcast produced by World Wildlife Fund. I'm Seth Larson. We've talked before on this podcast about the ways in which nature and human well-being are connected. My guest today has devoted his career to exploring the social costs that we pay when nature and biodiversity are undermined. Eyal Frank is an assistant professor at the University of Chicago's Harris School for Public Policy. His research has examined how the killing of sparrows contributed to famine in mid-20th century China, how the decline of certain bat populations triggered a rise in pesticide use that may have contributed to infant deaths in North America, and how the near-extinction of vultures in India could be connected to hundreds of thousands of human deaths. Today, we're going to focus primarily on that last story. You know, vultures play a fascinating role in our web of life. Most of us probably find them off-putting, but the truth is that vultures are nature's cleanup crew. When an animal dies, vultures consume the carcass before it can spread disease. But, as we'll hear today, vultures have been under threat from poisoning, and their populations have plummeted across Africa and Asia. That's why WWF is working with communities, rangers, and scientists to protect vulture habitat, stop poisoning, and track their movements to uncover threats before it's too late. One quick shout out before we get started. I came across Eyal's research thanks to an episode of Shocked, a podcast hosted by journalist Amy Harder and economist Michael Greenstone, and produced by the University of Chicago's School for Climate and Sustainable Growth. Please be sure to check out that episode as well. I'll be sure to include a link in our show notes. And now, here's my conversation with Eyal Frank. Okay, Eyal Frank, welcome to Nature Breaking.
Thank you for having me.
So I want to start this conversation by asking you a little about yourself, and I wanted to specifically ask what sparked your interest in studying this intersection of economics and ecology. Was there a specific moment or a specific experience that kind of set you down this path?
I think that starting with my undergraduate studies in economics and environmental sciences, I knew I was interested at these issues at the intersection of economics and the environment, and I started gravitating more and more towards like I want to work on something about ecology and economics. Those seem to be very hard questions. We didn't have what seemed to be amazing answers to understand the trade-offs that we might be making as we allow for more economic development, what we might be losing in terms of ecological losses.
Mm-hmm.
That seemed like something that I wanted to work on and potentially make a contribution to. During my PhD studies, I kept reading all of these papers coming out from ecology about how we're losing species left and right, and extinction rates are much higher than what ecologists think are their background levels, and how that might spell really high costs to humanity.
Yeah.
But there was never a great mapping towards here's a specific species, here's a specific outcome, here's a specific number, and some uncertainty around that number. And at some point, I realized that, like, that's roughly where the climate sciences were maybe a couple of years ago. The climate scientists were saying climate change is happening, this could be bad for society. And it took a while for social scientists to start to take that very seriously and start producing all of these different estimates about climate change impacts and how weather variability helps us to think about climate change and human well-being. And I thought, I'm really well positioned to make a contribution here. I've studied a lot of ecology, I've studied a lot of economics and causal inference tools. I can start connecting these dots we need to be taking what ecologists are telling us a lot more seriously and testing out all of these different theoretical predictions.
Yeah, that's a great point of comparison between biodiversity and climate change. That has been a huge challenge over the last 15 years or so with the climate movement of being able to attribute specific events to changes in climate that we're measuring. For so many years you would hear, well, we know that climate change makes hurricanes more frequent and more likely, but we can never say that this hurricane happened or was worse because of climate change. And that's flipped over the last 5 to 7 years, where the climate science community is now able to make some more direct links, obviously still with some caveats. But at WWF, I think, have felt like, obviously we work on climate change a lot, and that's an issue we care a lot about because it has such an effect on wildlife and ecosystems. But one thing we in our communications division talk about a lot is the importance of elevating nature and elevating biodiversity, and trying to bring more awareness to those topics to put it on a similar level of public consciousness with climate change. But that attribution is super important to doing that, because now that there is that attribution in the climate space, a lot more people, just in the general public, I think, have developed more of an understanding and an awareness of how climate change impacts their day-to-day life. And being able to make these links with biodiversity can do the same thing. And honestly, when I first heard about your study with vultures, which we're going to get into in a moment, I kind of had the same light bulb moment of, this is one of the most powerful examples I've heard of the ways that losing a species or an ecosystem can directly affect people. As I just mentioned, and as I alluded to in the intro to this episode, you've done this really interesting work on vultures. But before we get into that, can you just explain a little bit to our audience about why vultures are so important to ecosystems and kind of what role they play in keeping not just nature but also people healthy?
Definitely. So I think it's really important to first recognize that vultures are probably not going to be the likely potential winner of a popularity
Yeah,
contests if we were trying to rank species on cuteness. They're not the poster species you would put up as a mega charismatic animal that helps raise conservation
I
resources.
have behind me in my
Right.
office here a panda bear
Yeah.
and the WWF logo. Obviously, we
Yeah.
probably won't swap that out for a vulture anytime soon.
For obvious reasons, people don't have the most necessarily positive reactions when they see vultures out in the wild doing what they do. But what they do is they are what ecologists call obligatory scavengers. That means that they eat dead animals and they only eat dead animals. That also means that along evolutionary timelines, they've gotten very good at doing that, meaning that a pack of vultures can descend down on a carcass of a cow and consume it down to the bone well under an hour, in let's say like about 40 minutes or so.
Wow.
They've cleaned the animal down. Now, they're eating dead animals, which is not something that I advise to anyone who's listening to the podcast, but vultures can do that safely because their stomachs are about 10 to 100 times more acidic than ours. So
Whoa.
any kind of like bacteria or pathogens that they digest, that's kind of like, last stop for that. In a way, I love describing vultures as the great disinfectors of the environment. They're like spraying bleach over our surroundings. They take a lot of problematic, rotting flesh and just clear it out of the way. And not only do they do it for us, we don't have to bring the dead animals to them. They will find where the dead animals are, clean them up, and move to the next dump site, and just repeat this again and again. That function that they perform out in the wild provides us with this service of public sanitation, which could potentially be very prohibitively costly to try and replace and substitute should vulture species were to experience massive declines in their population levels.
Yeah. Okay, so let's talk now about this study that you engaged in regarding vultures in India. And actually, first, can you just tell me how you first became aware of this problem of vultures rapidly declining in India?
When I started working at the University of Chicago, Anand Sudarshan, who at the time was here, now is a professor at University of Warwick, learned about other work that I did about bat declining in the United States. And he taught that paper in a class that he was teaching.
Hmm.
And he told the students there that, like, oh, this study that Eyal did about bats reminds me of what happened to vultures in India. And one of the students there was like, why don't you talk to Eyal about this and write a paper on this? And Anat was like, I don't know if we can get the measurement right. Seems like it'd be really hard to do,
Mm-hmm.
but that kind of like sparked a conversation of him like, your paper really reminds me of what happened to vultures in India. And I was, what happened to vultures in
Huh.
India? And then he told me this story, and I was like, that is absolutely insane. There are all of these claims about what happened in the aftermath of vultures declining. Maybe we can actually test this with data and see if there's any support for those like anecdotal reports of a public health crisis in the absence of vultures. And then we had to just like lay down the foundations of like what data would we need, what would be like some modeling decisions we need to make, how what are the things we should be worried about in terms of interpretation, how do we test for that. And we embarked on this like multi-year project of like connecting the dots on that.
Wow.
From that, like just like being randomly the same institution at the same time and being interested in similar topics in environmental economics.
That's so crazy and so fortuitous that you both just connected in that way. And it's produced this really fascinating study that I want to ask you to talk a little more about. Can you walk us through? So you went through this whole process with your colleague of figuring out how to get your arms around this problem and what kinds of data you might need to find, and so walk us through the story. What did you actually find once you got into looking through the data and doing some research? What did you find in terms of what happened to vultures in India? And tell us why you found that they started declining in the first place.
So we relied on previous work that documented the decline of vultures. By the time that we started working on this project, it was well established that their populations decline of several species declined by over 95% in just a few short
Yeah.
years around the mid 90s. The cause of that decline took about a decade to figure out. But by the time that we started working on this was like kind of like hindsight wisdom. We already knew what happened.
Yep.
The gist of the story is that in the mid 90s, there was a generic approval for the production of a painkiller with the active ingredient called diclofenac. We might be more familiar with that painkiller under the brand name of Voltaren.
Uh huh.
If you have it in your medicine cabinet, I don't want you to throw it out. It is perfectly safe for use in humans. We have been using that painkiller since the 70s. It is very effective, very safe for people.
Hmm.
But with the generic approval and India's generic pharmaceutical industry kicking in and producing very cheap and very potent versions of that painkiller, the price went down so much that farmers started administering it to their livestock animals.
Huh.
It helped them overcome inflammations and fevers and just be, more productive and more docile and easier to manage. Seemed like a great idea. You have some new veterinary medication that you can give your livestock that's very cheap, that's improving animal welfare for like around 500 different million livestock animals across India. What could possibly go
What? Yeah.
wrong? Turns out, in hindsight wisdom, is that that residue of that painkiller, when consumed by specific vulture species, results in kidney failure and death within just a few weeks. So the first kind of like observations that the ecologist had is like, wait a second, why are like half of the vultures in my study site dead?
Yeah.
And started writing out to other colleagues of them, and they're like, oh, we're seeing the same thing. We just thought it's something idiosyncratic to our study site. And then within 2 3 years, like, okay, something's happening to vultures across the country. And a lot of different ideas were kind of like brought up, like maybe it's a wildlife disease,
Mm-hmm.
maybe there's like some, deliberate poisoning that's happening. And maybe there's some like an invasive species that's causing this,
Yep.
like all of these different thoughts until A paper by Oxalal got published in 2004 in Nature that said, like, no, here's the observational as well as the experimental evidence that it's this painkiller causing kidney failure in this species.
Wow.
But at that point, those populations declined by more than 95%.
Wow.
And that took just a few short years to happen, unfortunately.
So, just to back up for a second, I'm curious. So, you mentioned earlier how sort of durable the stomach gut biome of vultures is. It can digest all these dead animals without any problems. Why was this painkiller substance so harmful to vultures?
So I can't walk you through the exact kind of like pathophysiological mechanism here as to why that painkiller is completely safe to us, but ends up being the kryptonite
Yeah,
for
yeah,
vultures in a way. But essentially, their digestive system might be really good with getting rid of anthrax because that's what they have encountered in dead animals across their evolutionary timescale, but was completely unprepared for dealing with this man-made pharmaceutical active
huh?
ingredient in the name of diclofenac. And that unfortunately triggers a chemical reaction that leads to a biological reaction of their kidneys shutting down and failing, and spells absolute death even with a really low dose exposure.
Yeah. Okay. So you've collected all this information. There've been these pre-existing studies that kind of put some of these puzzle pieces together, but your research found that this collapse in vulture populations then led to a huge increase in human deaths, which was incredibly tragic. Um, Tell us what you found there in terms of how many human deaths were potentially attributed to this decline in vultures, and what exactly is the connection between vultures dying and then humans getting sick, and how did you attribute that cause and effect?
So, broadly speaking, in this field of applied microeconomics, and definitely in kind of like the subfield of environmental economics of that, we always start as trying to answer these questions by thinking about if we had absolutely no constraints whatsoever, like no budget constraints, no ethical constraints, what is the ideal experiment we would run to try and answer the question, or in this case, what is the importance of vultures for human health in this setting of India? And that would look like something would go around and at random just kill a lot of vultures someplace, introduce a lot of vultures somewhere else,
Yeah.
we'd randomly manipulate the population levels. For what I hope are obvious reasons, this is not something that academics go and ask their institutional review boards to sanction
Yeah.
and endorse and like say, yes, interesting question, go and decimate entire ecosystems to learn how important they are. What often happens is these weird occurrences that happen out in nature that give us a useful approximation of that ideal experiment, and we call them natural experiments. So for us, what we needed is some way to think about okay, vultures started to collapse very abruptly, unexpected, took a decade to even figure out what was causing it. And it all started happening in the mid 90s. We needed first to like really understand when the collapse started.
Yep.
And we had to do this like detective work, kind of like, the cork board with the red yarn of like looking at different approval documents of when the generic approval came into be, looking at studies that look at surveys that when people actually started using it in their livestock, and we were like, okay, 93, 94, that's when things started to happen for vultures. We were able to obtain some data on just overall pharmaceutical sales to really see both the price and the quantity being sold of injectable forms of diclofenac, which were more likely to be used in for veterinary
Mm-hmm.
purposes, kind of like price collapsing and sales exploding around that period of 93, 94.
Okay.
So there was like, okay, that's one piece of the puzzle. We kind of like have the timing more in place. We then went and started looking, okay, what happened to the share of observations of vultures in different, like, scientifically collected or citizen science collected observations on birds? Do we start observing a smaller proportion of the affected vultures relative to all of the other bird species that we might be reporting
Mm-hmm.
and collecting data on? And we start seeing that, like, okay, the share or that proportion is holding pretty stable until the mid 90s, until 93, 94, and then it starts breaking down and we see this decline in the proportion of vultures. Completely different database, by no means has to align with what we see with the sales of diclofenac, but the same timing aligns pretty well.
Yeah.
We started sending more diclofenac, presumably for veterinary purposes. At that time, we also start seeing fewer vultures in all of these reported collections on birds. What's next? Now let's try and bring in the human health dimension on this.
Mm-hmm.
So we were able to obtain all-cause mortality at the district level for each year. A really key limiting factor is that we didn't have mortality by cause of death, and we didn't have it by age groups at the geographic level of the district.
Yeah.
Those data became available much later relative to our study period.
Okay.
But we had at least an overall, for all causes of death, all mortality at the district tier level. What we needed is a way to classify the districts as how affected were you by the decline of vultures.
Mm-hmm.
To do that, we looked at the habitat range maps produced by BirdLife International, which we interpret as like the global authority about all things related to birds,
Mm-hmm.
and seeing how much of the district overlaps with habitats for the affected vulture species, and use that as a rough proxy for what was the equilibrium population level of vultures before they were inadvertently poisoned and collapsed.
Oh.
So what we ended up is with like some districts serving as a very suitable habitat for all three of the vulture species that were affected by the decline, and that most of the district, if not all of the district, was considered to be suitable habitat. Whereas in other districts, there were maybe suitable habitats for one or two of the affected vulture species. And in some districts, maybe you had some patches of suitability in some parts of the district, but not all of the district was considered to be suitable.
Gotcha.
And that just allowed us, like, we didn't need to know the exact number of vultures because no one really bothered counting them
Yeah.
in the years before the collapse because they were seemed like they were everywhere. Why bother counting
Right.
them?
It would be like counting pigeons in New
But
York City or something.
exactly, exactly. And we needed a way to rank or classify districts, like you're in the group that's been highly affected by this collapse, you're in the group that's been less affected. You might all also be affected, but not with the same severity as a district that's like prime habitat suitability for all of the affected vulture species. Using that ranking, we looked at how the mortality trends were evolving in the years before and the years after the collapse of vultures. And what we saw is that up to the mid 90s, there wasn't a differential trend, meaning that the places that we classify as highly suitable for vultures were following the same trends, or their mortality outcomes for humans were evolving in the same way that they were evolving in the low suitability districts.
Okay.
So there might have been like a baseline difference in mortality, but over time they were moving in the same direction. When all of a sudden, 93, 94, that period that diclofenac started being used in livestock, and we see the sales exploding, we see the share of vulture populations and observations go down, then we all of a sudden start seeing this divergence in mortality patterns. We start seeing that human mortality in high vulture suitability districts starts to diverge from the pattern that the low vulture suitability districts are on. And by the year 2000, we know that vulture populations essentially have hit sort of like rock bottom, or like the bottom of the barrel. Those species were classified as critically endangered. They went from anywhere 30 to 50 million birds across India at baseline to just a few hundred of them left out in the wild. So there was like no more where this like collapse can really go at that point. And that's also when we start seeing the difference between the high and the low vulture suitability districts saturate or stabilize. So it's not that um, in 93, the high vulture suitability districts started shooting up to the moon and mortality was just like skyrocketing and didn't stop. It went up and then stabilized, and there was like this consistent gap on average between these two groups of districts, and that difference is what we attribute as the increase in mortality of about 4% higher mortality as a result of the collapse of vultures.
4% higher
And then in the
mortality
rest of the
for
paper,
human populations in
for
those
people,
districts.
yes,
Yeah.
exactly.
Wow.
The human mortality rate in the high vulture suitability areas was 4% higher than what it was in the low. Now, this sounds like a really big effect, but again, it's important to remember we're not talking about a 1, 2, 3% decline in vulture populations. We're talking about a near collapse, complete local functional extinction of what vultures can do in the ecosystem. And we're talking about a country with a massive livestock industry with about 500 million different livestock animals, where the key technology to remove dead animals from the environment was
Yeah.
vultures. And when they're not there, you either get a lot of dogs and rats that show up and eat the dead animals, so you get a lot more dogs and rats, and they carry infectious diseases. In India, we're very concerned about rabies from animal bites from dogs. And, and what we're also worried about is having more dead animals out there in the open, rotting without any treatment, and all of those pathogens just leaching into drinking water, and what that means for human health as well.
Wow.
So, those were the two main mechanisms that public health experts were worried about. Now that vultures are not around, we're getting more of the inferior technology, dogs and rats, and getting much higher levels of water pollution as well.
Interesting. Okay, so that there's a lot to unpack there. Just to sort of recap where we are so far, in the mid 90s, 93, 94, this painkiller medication became available as a generic medication and became very prevalently used with livestock in India. The vultures were eating all these livestock when they died. The vultures were then dying because their bodies couldn't process that chemical. Took years to figure out that connection. In the meantime, vulture populations in this area crashed by 95%. And without vultures there to clean those carcasses, then we saw an influx of dogs and rats to clean those carcasses in, as you said, a less efficient manner. And those animals are much more likely to spread diseases that vultures wouldn't be spreading. So, and you just mentioned rabies and spread of other diseases. So, were you able to then take all that information and make any determination about whether there were upticks in those specific uh, causes of fatalities for people that explains this 4% spike in human deaths in those districts?
That's a great question. I will say that we offer at best very weak and suggestive evidence for those two
Okay.
mechanisms in the paper, not because we were lazy or didn't think it would be important to make that case for better quantitative evidence on those mechanisms. We were very limited with what we were able to measure about either one of those. Water quality is monitored in India, but we don't necessarily test for the presence of anthrax in the water, for example, or for many other different bacteria or pathogens that might exist as a result of a collapse of vulture populations and larger rotting dead animals out in the open. Also, it's a problem that we don't have a lot of monitoring stations and that they don't operate consistently across time. So we have like stations entering the sample, leaving the sample. That's a mess for the purpose of like clean, coherent data analysis. But we are able to see a big increase in fecal coliforms in the places that experience a bigger collapse of vulture populations. We are able to see these larger increases in biological and chemical oxygen demand. We're seeing less dissolved oxygen, which are all of these like different metrics that we would expect to see now that there's more organic matter, especially from livestock, flowing into and ending up in underground waters or in wells. So that kind of like, oh, there's a difference all of a sudden in terms of how water quality is changing and it's deteriorating systematically in the places that we think experienced a bigger decline in vultures. So that was one, point of suggestive evidence we were able to offer on that mechanism.
Okay.
For rabies, we unfortunately don't have good data on the count of rabies or the incidence and the prevalence or the number of animal bites at a fine scale level that we can attribute to dogs. There are also a lot of animal bites that happen just from snakes. And any data that we were able to find on animal bites lumped everything together. Animal bite from snakes, from dogs, from rats, from pigeon, or whatever. Just like an animal bite is an animal bite. And there was like, that's insufficient to say something uh, conclusive or definitive or useful about rabies. What we did have is some data on the sale of vaccines for rabies, which is the first kind of like line of treatment that you get after potential exposure to a rabid animal. If you show up to the doctor's office in the US and say like a bat just bit me, they'd be like, well, here's a rabies shot, and let's hope that that will do it, because there's some danger of exposure there. So that's the same thing true. If you are bitten by a wild feral dog in India and you go to the doctor's office, the first thing that they'll do is give you a rabies vaccine shot. What we see is that the number of vaccines again skyrockets or like jumps up around the mid 90s, around the time that all of these other patterns are changing, but we're only able to see that at the national level. So we see this increase in the sales of rabies vaccines, and we see it more or less saturating pretty quickly after 2000. And so that was like, again, weekly suggesting that rabies incidence has gone up right around the time that we also know that vulture populations went down and that people complained that there were more dogs out in the street. There's surprisingly a livestock census in India that, at least in recent years, is also counting dogs, regardless if they're like domesticated or feral or anywhere on that continuum of like, somewhat feral, somewhat domesticated. So we use the measurements, I think, from 2012 and just try to compare that to the baseline vulture suitability for the affected species. And we do see a linear relationship that like we see more dogs being counted in places that presumably had more vultures collapse around that timing. So that's like another kind of like piece of the puzzle. Is like we can't say anything very granular or like the change in the district about dogs or rabies. We see more dogs in places that probably lost more vultures.
Yeah.
We see overall more sales of rabies vaccines after vultures collapse. That tells us something about the validity of that mechanism, but very suggestive at best on that mechanism.
Gotcha. Okay, so at a minimum, your research showed this 4% increase in human death rate in these districts that saw a bigger loss of vultures. And there's these leaps of logic that we can at least take to say, well, there are some clear risk factors for human illness or death that would naturally go up with the loss of vultures, and there's some evidence on the margins to suggest that rabies may have been going up and that dog populations maybe were going up and bringing rabies with them. But at the end of all this, were you able to make a educated guess about how many people in India may have died because of this whole chain of events?
So at the end of all of the analysis, we take that 4% average on increase and try to come up with what do we think has been the excess mortality as a result in the kind of like, post collapse equilibrium. So like after 2000 up to 2005, and we end our analysis in 2005 because at that point we understood the reason. And in 2006, India placed an ineffective ban, but a ban nonetheless, on the veterinary use of diclofenac. So like a lot of stuff potentially have changed after 2006. So that's where we ended the analysis. But in that 2005 period, we calculated about 100,000 additional deaths a year occurred across the districts
Wow.
that experienced this collapse of vulture, which is a massive number. But again, India is a massive country, and we're talking about potentially what is a complete collapse of environmental sanitation. You asked me earlier, how did we tease out kind of like the cause and effect of
Yeah.
this? So a lot of what we spend, maybe not in the main text of the paper, but in this really long appendix to the paper, and definitely what we spend the longest whenever we presented this is like what tires can we sort of like kick on the analysis and see where things potentially break? Like, what kind of other explanations can we rule out for these observed patterns? So we do a lot of drawing on data from the census to reject that this is not because places that experience this higher mortality saw also a collapse of their just like healthcare access. We don't see fewer hospitals. We don't see fewer doctors or midwives and nurses per thousand people. We don't see lower developments in infrastructure. We don't see lower literacy rates. We don't see lower patterns of investment in public infrastructure. All of these, like other potential things that might happen, don't seem to offer a good explanation. We don't see that weather variability is capturing these. So it's not that somehow these places were also differentially exposed to climate change, and that's what's getting lumped up in the all-cause mortality rate. And we do another finer breakdown of, I told you how we needed places going from having a lot of vultures to having very little vultures, but for that to matter, we also needed there to be a lot of livestock present
Right.
for this to be meaningful. So we use the livestock census, which we have some data also in the years before the collapse, and we can classify places as having a lot of livestock and maybe not so much livestock before vultures collapsed. And then we're able to show that vultures declining from high to low only matters in the places that had a lot of livestock, or matters a lot more in those places relative to the places that had little livestock agriculture at baseline, or like that um, elevated mortality is driven more by the places that were also big on animal agriculture at the beginning, even when we're making comparisons within the group of districts that were just as suitable for vultures, but were maybe had differences in livestock agriculture. So this combination of all of this kind of like collage of evidence of like these different pieces of, it's not these alternative explanations. It's happening and concentrated more exactly in the places where our ecological and public health theory is telling us that it should be happening more in, shows up in the data as well. All of that helps to support that interpretation of like that 4% increase in mortality is not a spurious effect, and translating that into a 100,000 additional human deaths a year as a result.
Wow. Yeah, I mean, at the end of the day, 100,000 people is 100,000 people. That's just really devastating. And to think that there's a direct connection between this sort of just accidental chain of events that happened with vultures declining is really sad. And to think it could have been prevented, but we didn't have that knowledge at the beginning. You kind of start pulling at that thread, and but at the end of the day, it just makes me really sad to think that all those people were lost because of this decline in vultures. Um, I want to move forward and just ask you a couple more questions before I let you go. Just thinking about that impact on people that your research illuminated, what lessons do you think policymakers and the general public at large should take away from this case about the hidden costs of losing a species, even, as you said earlier, if it's not one of those cute and cuddly species that we all love so much?
I want to start by saying that I don't want to push the interpretation that every species lost is going to be as catastrophic as the loss of vultures
Sure.
in India. There are potentially many species that are going extinct, and much harder, if at all, to make a link between them and human well being. It is also true that there are many other settings where we might lose vultures or already have lost vultures, and the human toll has not been as high as it was in India. There's really a combination of a lot of different circumstances that made the specific loss of vultures in India be this catastrophic.
Yeah. Thank you for
I
noting
think
that.
that the broad, yeah, yeah, yeah. I think that the broader takeaway here is that we keep thinking about, we have all these species in decline and we need to preserve and conserve and maybe prevent local and global extinctions. How do we triage? How do we make sense of where to best spend our very scarce resource conservations?
Hmm.
Unfortunately, we don't have an open check to go and save everything and everyone out in the wild. We need to make some tough decisions. And what has guided so far our decisions, a lot of it, I think, has been just like how cute the animal is, how likely is it to go viral as part of a campaign.
Yeah.
Whereas if we think about the functioning of the ecosystem and the benefits that we get from a well-functioning ecosystem, we want to think about specific species, specific functions, and especially there's this term that ecologists like to use, keystone species.
Yep.
The species that if we lose them, we'll experience a disproportionate change in the functioning of the ecosystem relative to their abundance in that system. And vultures by no means were the largest species in terms of like their biomass, but losing them in terms at least of their functional capacity to perform that role of environmental sanitizers spelled out this chain of events that was highly consequential.
Yeah.
So if we think both of where we need to direct different conservation resources, perhaps thinking through the lens of keystone species helps guide how to make those decisions. But also we often talk about the precautionary principle, and it's not that we should apply it broadly anywhere to everything. It's really hard to go and demonstrate that using a diclofenac is going to be safe across the entire chain of exposure. But to think who might get exposed to diclofenac now that we're using it in livestock? Oh, is one of those potentially exposed animals a keystone species in that ecosystem? Vultures. Yes. What would happen if we lose vultures? Not great. At least that's what our theoretical models and understanding tell us. Let's just test how sensitive vultures are to diclofenac exposure. Oh, they're really sensitive to it. Hold on, let's stop. So that's like a case where we could have not gone with the precautionary principle all the way that like we need to demonstrate that glufosinate is safe for any organism out in the wild, but there are some organisms that will definitely get exposed to diclofenac now that we're using it in livestock, and some of them fall under that umbrella of keystone species, and we have some theoretical understanding as to how badly things can go wrong if we lose vultures, that we could potentially have prevented this decline if we had that approach to the precautionary principle.
Yeah. I think that's a really useful lens to think about this through. Um, Well, Eyal, thank you for walking me through all of this. I'm mindful of time. I don't want to take too much more of yours, but before I let you go, I did want to ask. You've done this really interesting research on vultures. I mentioned in my intro the research you've also done on sparrows and bats, and some of the effects of losing localized populations of those species had on people and nature. I'm dying to know what's next for you. Is there a species that's next on your list that you're starting to look into, or what's next on your to-do list?
There's a bit of more recent work that I've done with a few co-authors on wolves,
Mm,
sort of like extending some prior studies by Jennifer Rainer et al. That came out in 2021 that demonstrated how vehicle collisions with deer tend to go down after wolves recolonize in Wisconsin.
mm,
We tried to replicate that using a different method, using a different empirical setting, and that's like one study that we're sort of like wrapping up now. Another in the system of wolves is that like okay, they might be generating some benefits, but people often complain about the risk that they present to livestock operations. So what can we say and measure about those risks? How many more livestock predation events happen as a result of wolves recolonizing across their range?
yeah.
Those, I think, are like two important additional studies that help us think about the reintroduction and rewilding of ecosystems by bringing back apex predators that we have either intentionally or unintentionally removed from the wild. And in a different project, I'm trying to get at an answer. What do we actually understand is the benefit for agriculture of having well functioning pollinators in an
Mm,
ecosystem? And we've sort of like always brought up pollination as this like canonical textbook example of ecosystem services, but just how big is the contribution to agriculture and for different crops is something that I want to contribute a better quantification to.
Super interesting. Well, Eyal, please keep us posted on that research as it goes forward. I'm definitely looking forward to finding out what the results of those studies are. And thank you for taking the time today to walk us through your research on vultures. I really think it's important stuff to be able to make these connections between losses of species and effects on people. I think it really drives the conversation forward in terms of helping our collective community see the value of nature and see the value of biodiversity and hopefully elevate it as a priority in all of our lives and then apply that to public policy arenas and what have you to really make a difference. So thank you for the work you're doing on this, and thank you for joining Nature Breaking today.
Thank you for having me today.
Thanks again to Eyal for joining and walking us through his research on vultures. Before we go, I wanted to share a little more with you about how WWF is working to conserve vulture populations around the world. In Zimbabwe, we started a program to collar and track vultures to learn more about their behaviors. This helps us refine conservation plans by identifying migratory routes and habitat use. It also helps us track changes in ecosystem health and even provides important information about poaching. As we know, and as we heard today, vultures are always on the lookout for animal carcasses, so tracking vulture movements can sometimes lead us to sites where poaching has occurred. In Pakistan, WWF has worked to establish vulture safe zones where special care is taken to ensure they have access to food sources that are free from the harmful pain medication that we heard about earlier from Eyal. Those are just a couple ways we're working to make a difference. I hope today's episode helped you think a little differently about vultures and helped you understand the important role they play in modern society. For now, thank you so much for listening, and together, let's keep building a more sustainable future.